and its perimeter. The polygon is at 1, 5, negative 4, 3, 1, 1, and 3, 3. So to classify it, if we just look at this figure, it appears to be a kite. But in order to verify that, we do have to find the length of each side. Now, one thing I want you to remember is we have two options here. You can write down each of the points and use the distance formula, or you can do the Pythagorean theorem. A lot of you preferred the Pythagorean theorem, so if that's what you would like to do, you can do that. I'm going to show you one where I do the distance formula, one where I do the Pythagorean theorem, and you can make your own decision there. Okay, so first let's use the distance formula. So I'm finding the distance from A to D. Okay, I'm going to have to find for all three sides. So I write down A and D so I can plug them in the distance formula. Okay, so if I use that distance formula, I'm supposed to, hopefully you have that written in your notes. Remember, the distance is the square root of x2, this x from my second point, minus x1, the x from my first point squared, plus y2, the y from my second point, minus the y from my first point squared. Then we start to simplify. So 3 minus 1 gives me 2 here, and 3 minus 5 gives a negative 2 here, and I get the square root of 2 squared is 4, negative 2 squared is also 4, because negative times negative makes positive, and I get the square root of 8. So the distance from A to D is the square root of 8, which I may simplify in a little bit, but for now I'm just going to leave it that way so that I don't have to do any rounding. Okay, let's go ahead and move on to the next one and go from there. Okay, now let's find the length of CD. Now if these two are the same, that's a good thing, because it means there's a good chance this is a kite, like we were guessing. Okay, so I'm going to write down the points C and D. We're working with C and D now, 1, 1, and 3, 3. Use the distance formula, so we do x minus x, so 3 minus 1 are our x's, plus y minus y. So again, remember that means the y from this point was 3, the y from this point is 1. We get 3 minus 1 here also. We continue and simplify. So 3 minus 1 gives me 2 squared for the first part. 3 minus 1 gives me 2 squared for the second part. 2 times 2, 2 squared is 4, and 2 squared is 4. And again, I get the square root of 8. Okay, so CD has a length that's also the square root of 8. And I'll go back later and do those with my calculator to find out exactly what number they are. But for now, that works. So I can see those two sides are congruent. Now I'm going to find the length of AB. So let's work on the other side. So the line from A to B here. I'm going to write down the 2 points so that I have them as a reference. Point A was at 1, 5, and point B is at negative 4, 3. I'm going to plug them into the distance formula. So here we go. X minus x. So my x's are negative 4 and 1. So negative 4 minus 1 squared. Y minus y would be 3 minus 5 squared. So notice I subtracted my x's, subtracted my y's. Let's simplify that so we can figure out what this number is. Negative 4 minus 1 is a negative 5, and 3 minus 5 is a negative 2. I square each of those. Remember, this means times itself, so negative 5 times negative 5 is a positive 25, and negative 2 times negative 2 is a positive 4, and I end up with the square root of 29, which again, later I will go back and write down the decimal for that, but for now, just to keep my board a little clear, I'm going to just write that. Alright, we have found 3 of the sides. The only one we have left is BC. I'm going to draw a line here. Okay, so if we're going to go from B to C, let's write down those points. B is at negative 4, 3 is what they told me in the instructions, and C is at 1, 1. Let's use the distance formula. So again, we do y minus y, or x minus x, excuse me. So 1 minus negative 4. Squared plus, now subtract the y's, 1 minus 3. Squared. Here we have minus a negative, which remember always becomes a plus. 1 plus 4 is 5. And here 1 minus 3 is negative 2. Square each of those. 5 squared, 5 times 5 is 25. Negative 2 squared, negative 2 times negative 2 is 4. We add them together and we do get the square root of 29. So that is a lot of work to classify this figure. We know it's a kite now because we have two pairs of congruent sides that are next to one another. Okay, so I can now classify. When it says classify, what is this figure? It's a kite. Whew. Job number 2 was to find the perimeter. Okay, so the perimeter is the distance around the outside of the figure. So now I'm going to go ahead and take my calculator and find out what the decimal, they want it to the nearest tenth. So I'm going to use my calculator and do the square root of 8. The square root of 8 is about 2.8. It's 2.82, but they wanted to the nearest tenth, so just one decimal place after. That means this one's also 2.8. Let's come up here, the square root of 29, what number is that? It's 5.38, which rounds to 5.4. And this one's also 5.4. To find the perimeter, we add the sides together. Okay, so my perimeter is going to be 2.8 plus 2.8, which you could write as 2.8 times 2 if you want, and then plus 5.4 and another 5.4. Again, you could write that as 2 times 2.8 plus 2 times 5.4. When I add them all together, I get a perimeter of 16.4 units. And I'm done. Okay, so if you like using the distance formula, you can just take that as your example. If you would prefer to try it using the